Fuses protect the appliance. It's a device that's used to protect. It's a device which is used to protect appliances from currents which are too high. The symbol is a box with a line through it, and you can see the line in my diagram there. You maybe can't see it too well, but there is a line straight through it. So how does a fuse work? So you know what the fuse does. It blows or breaks the circuit when too much current flows. Okay, so every circuit or every appliance has got a certain amount of current which it operates normally at, and that might be 5 amps, 8 amps, 10 amps, whatever it is. If more than that flows in the circuit, that's going to damage the circuit or damage the appliance in some way. Now, most appliances have a normal operating current, say of 6, 7 amps, but they will allow a little bit more to flow through before the fuse will blow. So we're going to do a wee calculation to see how, first of all, do you calculate the amount of current that's needed in a normal circuit, and then what size of fuse you would choose after that. So this is how you calculate the suitable value of a fuse. First of all, choose a fuse with a value above the operating current of the device. So you need enough current to allow your device to work. In this case, if a kettle operates with an electrical current of 4.3 amps, it needs 4.3 amps to allow the kettle to work. So the fuse you should choose should be above that. Now if we look at the picture here, we've got 5 amps, 3 amps and 13 amps. And the nearest one just above it is 5 amps. So that kettle will allow 4.9 amps to flow through it, but when it gets to 5 amps, it blows. And that protects the kettle. You won't know there's anything wrong, you'll just see that it stopped working, and maybe you need to change the fuse. But if that happens again, then obviously there's something a bit more serious than that, and you need your kettle checked out. Right, so we're going to just choose a few more fuses. Operating currents here, there's one of 2.1 amps, so we need something above that. So the next one up there is 3 amps. 11.2 amps, we need the next one above it is 13 amps. 4.7, the next one above it is 5 amps. 6 amps, now this is a funny one because it will allow up to 13 amps to flow before it breaks because there's no other fuse in there. So your device is fitted with a fuse suitable for it. This appliance normally operates at 6 amps, but it will require a 13 amp fuse. If there's a 10 amp fuse available, maybe they'll put a 10 amp fuse into it, but they will not fit a fuse into an appliance which will allow it to blow the appliance. So it will allow up to 13 amps to flow before it breaks. 5 amps. And 8.2 amps, again, you're going to have to choose the next one up, which is 13 amps. So of course, at any time, if you want to do some of these calculations, just stop your video cast, do your calculations, and then check the answers. Now, this is how you calculate the size of current and then the size of fuse. Remember your electrical equations, so this is just a wee reminder. Q is IT, E is power by time, voltage is current by resistance, energy is current by time by voltage, and power is current by voltage. So we've got a 60 watt lamp operating on a mains voltage of 240 volts. What current is flowing through the lamp? Okay, so you may have to do a calculation for this, and again you can stop the video cast if you like. First of all, we're going to choose an equation which has got power and voltage, and we're looking for current. And so P, I and V, of course the calculation is P is equal to IV, so this is part A. So you write down the equation, P is equal to I times V, power is 60, I we don't know, and V is 240. So to get I, what you're going to have to do there is divide your 60 by your 240. So I is equal to 60 over 240. And then I comes out to be 0.25 amps. So we have to choose a fuse which is slightly higher than 0.25 amps. We can choose from 1 amp, 3 amps, 5 amps and 13 amps. So our fuse value is going to be 1 amp. You can see that there. Right, now very often there's a question that says, how do the fuse and the earth wire protect the user? So I've already explained this a bit, I'll just go over it again. If you have a short circuit through your case, and I'll put this in red maybe, then if a user could come along and touch that and experience a severe shock because they've connected a path down to the earth. What happens is that the current flows through the case and through the live wire safely to the earth, because the earth wire has got very little resistance and allows lots of current to flow. However, that current is much larger than normal, and when it goes through the fuse here, that means a large current flows, goes through the fuse blows, and that protects the user. They won't feel a shock. A little bit about the circuit breaker. A circuit breaker is a device which detects a current entering and leaving a circuit, and it switches off if there's too much current. Now very often you'll be given an exam question and your circuit breaker has got an electromagnet in it. So that electromagnet normally might have a normal current flowing through it, and the switch is sitting up here. However, if too much current flows through it, then because the switch will be made of something made of iron, it will be attracted to the electromagnet, it will move down, and that's broken the circuit. Now all you will know is that the trip switch, we call it the trip switch at home, I'm sure you know where all your trip switches are, it will have gone off. And you might just go out, check your circuit board and put it on again and your circuit's fine. So it's just detecting, sometimes this happens, you might have a power surge, maybe your electricity is coming back on again after a power cut or something like that. And when that happens, your circuit breaker will protect your circuit and make sure that it's not too large, the current isn't too large. So what happens is, again, too much current in the electromagnet, which is at a normal operating voltage, it won't be strong enough to open the switch. The switch will be closed, the circuit will be working. But whenever too much current does flow through it, it will move down, it'll be attracted down to the electromagnet, breaks the circuit up here, and the circuit's not working anymore. And that switches off the current. Now sometimes you might be asked about the advantages of fuses over circuit breakers or circuit breakers over fuses. So if you use a circuit breaker, it detects very small changes in current. So this is a circuit breaker. It protects the user. And to fix it again, or whenever it stops working, all you need to do is put the switch on again. So all it needs to be done is switched on easily again. So I should have said protects user and the circuit. A fuse only protects the circuit. And you have to change a fuse. So you may have to go and buy one, open your plug, change your fuse in your plug. And that's a disadvantage.